Salutations. I hope you're doing well. I hope you're staying safe. I hope you're still continuing to social distance yourself, staying home, and continue to wash your hands. Okay? Alright. So today we're going to move into chapter 7, and we're going to look at section 7.1, which is quadratic equations, the square root method, and completing the square with the lead term or lead coefficient equaling 1, where a equals 1. So, with that being said, I want you to take a minute, pause the video. I'm going to get out the way, copy down the notes that are on the board, and we'll be right back. I'm back. Let's get started. Okay, here we go. Square root method. So in order to use what we call the square root method, we have two conditions. Condition 1. If x squared equals c, then there are two possible outcomes. Then x equals the square root of c, or x equals the negative square root of c. Those are your only two possible outcomes if our condition is true, x squared equals c. If that's the case, two outcomes. Then x equals the square root of c, or not and, or x equals the negative square root of c. Okay? Alright. Condition 2. If the quantity of x minus a squared equals to c, and x minus a equals plus or minus the square root of c, in essence all we did was take the square root of both sides here. Okay? So if this and that, then what can we conclude? We can conclude that x equals a plus the square root of c, or x equals a minus the square root of c. Please notice what I have kind of what I've captured in red. That's important. And for condition 2, what I've captured in green, that's very important. Those are the primary things that I want us to kind of focus in on, okay? All right, so for the square root method, let's do some examples. Here we go. Let's jump right in. Example 1. All right. Example 1. Solve for x. Here we go. Let's say we have 2x squared equal 100. Let's solve that for x. Well, the first thing we have to do, if we want to solve for x, we have to isolate x. So first you must divide both sides by 2. No brainer. Here we go. Divide left side by 2, right side by 2. The 2's cancel out. We're going to have x squared equals 50. Alright, so far so good. At this stage, we have to take the square root now of both sides, right? So I'm going to write this again. I'm going to write x squared equals 50, right? And now I'm going to take the square root of the left side plus or minus the square root of the right side. Okay? So now we have to square root each side. Well, what do we do from here? Well, if you do not know what to do at that step, then you might want to go back and look at lesson 6.1. Because in lesson 6.1 we talked about this. We did this in lesson 6.1. That was a critical lesson as we go forward. 6.1. Everything square root or cube root or any root, 6.1. Alright, come on. So from 6.1, we know that the square root of x squared equals the absolute value of x, or just x, principal root x, which equals, now in this case, we have two conditions, plus and minus. So we got to consider both. So this means that x equals the positive square root of 50, or x equals the negative square root of 50. So it's the positive and the negative. You see that? It's the positive and the negative. You got to consider both of them. The positive square root of 50 and the negative square root of 50. All right? The only thing is we can't stop right here. Because why? We have to break down 50. So once again, you have to go back to lesson. Guess what I'm going to say? Lesson what? Yeah, some of you got it. 6.1. How do you break down the square root of 50? Let's do it. Okay, let's take it up. All right, so the square root of 50. Let's break it down. 50 is 5 times, well, it's going to equal what? I don't know what it's going to equal. 50 is 5 times 10. 5 is already a prime number. 10 is 5 times 2. So I have all my prime numbers here. And remember, you have to group by 2's because of index. Our index here is a 2. So we have to group by 2's. Here's one group. Here's a group. Only one up here. That one. So that means that this 2 right here goes back on the inside because it's not grouped. And of the group, only one goes out front. Only one. The 5 goes here, okay? Only one of them goes out front. And there you go. So when you break down the square root of 50, it is 5 square root 2. So our final answer is going to be x equals 5 square root 2, or x equals negative 5 square root 2. And there you go. There you go. That gives it to us. So that's the values of x. X is either positive 5 root 2 or x is negative 5 root 2. Either one of those values would do to cause this to be a true statement if you substituted in for x. They're true. Okay? Alright, let's go to example 2. Okay, example 2. Example 2. Same instruction, solve for x. Let's say this time 3 times x minus 1 squared equals 96. Solve for x. Step 1, divide both sides by 3. This coefficient of 3 out here, divide it through on both sides. So divide left and right side by 3. The 3's here are going to cancel, go to 1. So I'm going to have the quantity of x minus 1 squared, and that's going to equal 96 divided by 3, or 3 going to 6 twice, and 3 going to 9 3 times. 32. Alright. And at this step, take the square root of both sides. That's why it's called the square root method. Square root both sides. So, if I do that, I'm going to have x minus 1 squared equals 32. Notice how I wrote it all over again. Same thing. I just wrote it again. Right? Now I'm going to put the square root sign on both sides. I want the square root the left side and plus or minus the square root the right side. You have to do the plus or minus because x can be either value. Either value makes the statement true. It's like, listen, if I say that x squared equals 25, that means x squared is 25. If I write it again, watch this. If I square root the left side and then plus or minus square root the right side, this means that x equals plus or minus 5, which means x equals negative 5 or x equals positive 5. Those are the two answers. Those are your two possible answers, two possible solutions. And let me show you why. I'm just giving you a little bit of understanding of why we're doing this. using something that's pretty simple. Okay, let me show you why. Because if I take -5 and put it in for x, if x squared equals 25, then -5 squared should equal 25. And -5 squared is -5 times -5. That should be 25. And a negative times a negative is a positive. So 25 does equal 25. So here I'm good. I'm good with that one. Well, what about if I use -5, I'm good. Well, what about if I use +5? Am I good? Well, let's see. X squared equals 25. This time use +5. +5 squared equals 25. And this is going to be 5 times 5 should equal 25. And 5 times 5 is 25, which means I'm good. So notice this, both of them work. -5 squared is 25, +5 squared is 25. So both of these answers work. They're good. They give me solutions. They let me know that they both can be multiplied by itself and give me 25 as an answer. So I got to consider the positive and the negative. You see? So that's why you got to go plus and minus. You got to go plus and minus because either one of them is going to give you a solution in this case. All right? But as we go forward, well, as you go forward, it's beyond the scope of the class, but as you go forward, you'll see when you're solving quadratic equations like this, equations that involve even radicals, you have to be very careful because there's something called extraneous solutions or a false read, if you will, that may appear to be an answer or a solution, but in actuality is not. Okay? Even though both of these numbers will give you 25, we do know this is true. We do know that -5 does not equal 5. We do know that. Even though -5 squared does equal 5 squared. We know -5 squared does equal 5 squared, but yet -5 does not equal 5. But that'll come later as you go forward, but not right now. Okay? All right, let's get back to our problem. So we have to consider all solutions, the plus and minus. That was the point we were making, the plus and the minus. All right, here we go. So the actual square root cancels out the square, and I'm left only with x minus 1 equals plus or minus the square root of 32. All right? At this stage, we need to break down the 32. Okay? Well, we'll break it down in a minute. Let's go a step further. Let's subtract 1 from both sides. -1, -1. I'm sorry, add 1, not subtract it. It's already minus, so add 1. Add 1 to both sides, because we already have a -1, so add 1 to both sides. So over here, we're just going to have x. And what does x equal? Ladies and gentlemen, this is very important, this next step right here. Because you have plus or minus the square root of 32 plus 1. Okay? Write this number, the positive 1, that represents like the A. Write that number first. Do not try to add or subtract root 32 plus 1. You can't do that because they're not like terms. Okay? So, this number, write that first. 1. And then write this number next. Plus or minus the square root of 32. That's how I always want you to write it. Follow that order, just like I have it right here. See, I have the radical second and the number first. Write the number first plus the radical. Plus or minus the radical. So x equals 1 plus or minus the square root of 32. Okay? So we know that x now equals 1 plus or minus the square root of 32. And if you think that we're done with this problem, unfortunately we're not. Because now what must we do to the square root of 32? You already know. You have to 6.1 it. You have to break down the square root of 32. Okay? So, let's do that. Let's isolate this fellow right here. So we can break them down. The square root of 32 equals what? Let's go. Here we go. 32 is 8 times 4. 8 is 4 times 2. 4 is 2 times 2. And 4 is 2 times 2. Bring this 2 down. Bring this 2 down. Bring this 2 down. And my index here, of course, is 2, square root. So we have to group by 2's now. Okay. I have a group here. I have a group there. And that's it. What did not get circled goes back inside. So this 2, get on back in there. What did get circled, only 1 per grouping goes out front. Only 1. So for this first grouping here of 2's, I have a 2 times. For this second group of 2's, I have another 2. And that's it. And so this is going to equal 2 times 2 is 4. 4 square root of 2. So 4 square root of 2 is the same as the square root of 32. So we got it. So now we can go back and simplify our answer. So then if that's be the case, and it is, then x is going to equal 1 plus 4 square root 2, or x equals 1 minus 4 square root 2. All right, and those are our answers right there. There you have it. Here's one possible solution. Here's the other possible solution. And there you go. That's it for number 2. That's the square root method. Solving for x using the square root method. All right. Example number 2 is done. Okay. And please bear in mind, if you say, Mr. Wright, slow down, you're going too fast. Stop the video or rewind the video. Look at it again. Stop it, pause, whatever you need to do. Okay? All right, let's go. Example 3. Let's see. What's example number 3? All right, how about, what if we have, let's switch this up. Let's solve this time for y. Solve for y. Example 3. What if we have 4y plus 4 squared equals 48. Solve it for y. Solve for y. Okay, here we go. There's nothing, no lead coefficient here to divide by. So I'm going to go ahead and write it again. 4y plus 4 quantity squared equals 48. I'm going to square root both sides. Square root the left. Plus or minus, square root the right. The square root and the square cancels. So the square root and the square cancels out. And I'm left with 4y plus 4. And that equals plus or minus the square root of 48. So far so good? Come on. Now I'm going to subtract 4 from both sides. Minus 4. Minus 4. On this side over here, the 4's cancel out, so I'm going to get 4y. And it equals. Now remember how we told you to write it. Remember what we said. You see this minus 4? Write that first. Minus 4. And then write the plus or minus 48. Plus or minus the square root of 48, pardon me. is plus or minus the square root of 48. All right. At this stage, we can go ahead and break down the square root of 48. Let's see if we can break it down. All right, let's go get it. The square root of 48, what is that? What does the square root of 48 actually equal? How can we simplify it? Let's go. 48 is, let's go 8 times 6, and 8 is 4 times 2, and 6 is 2 times 3, and 4 is 2 times 2, and bring down this 2, and bring down this 2, and bring down that 3. You see that? Be very careful and line it up nicely when you bring these numbers down. These prime numbers here. They're all prime numbers. Our index, of course, is 2, so we're grouping by 2's. All right, here we go. Here's one set. Here's another set, and that's it. The 3 did not get grouped, so 3 goes back in. So 3, you're going back in. All right, and you take one number for each group. So 1, 2 represents this group, 2 times, and 1, 2 represents that group, 2, which is going to give me 4 square root of 3. All right, so that's what this radical 48 is, 4 root 3. So when I go and rewrite this now, here we go. So now let's take this right here. We're going to have 4y equaling negative 4 plus or minus 4 square root of 3. Okay? Now go ahead and divide everything by 4. Divide the left side by 4, divide negative 4 by 4, and divide 4 radical 3 by 4. The 4 here cancels out, goes to 1, so I have y equal negative 4 divided by positive 4 is negative 1 plus or minus, and these 4's cancel out, plus or minus radical 3. And there you go. Now it's simplified. There's your answer. Okay? So we have y equaling negative 1 plus the square root of 3, or y equaling negative 1 minus the square root of 3. And those are your two possible solutions right there. All right. You good? Everybody got it? Want to do one more? Or no? One more? All right, let's do one more. Then we're going to move on. One more. One more. Let's, this is example 4. Let's solve it for x. Let's go back. Let's finish how we started. Solve for x. Let's say that x squared minus 75 equals 0. Solve for x. Very simple. Add 75 to both sides. Plus 75 plus 75. All right, so we're going to get x squared equals 75. Not too bad. I've isolated x squared by itself, so now write it again. Square root both sides. Square root of x squared plus or minus the square root of 75. And so the square root and the square cancel, so I want to have x equals plus or minus. What's the square root of 75? Break it down. Radical 75 is radical what? What goes in? What goes out? I don't know. Let's break it down to prime numbers and see. 75 is 3 times 25. And 25 is 5 times 5. And I bring this 3 straight down. And that's good because I have all prime numbers. And my index is 2. So group by 2's. There you go. What did not get grouped goes back in. So this 3 here goes back in. And what did get grouped, only 1 goes out front to represent the group. All right, there you go. So the square root of 75 equals 5 root 3. So we can go back here and write plus or minus 5 root 3. So this means then that x equals 5 square root 3 positive, or x equals negative 5 root 3. And those are your 2 possible solutions. And that's it for the square root method. Okay? So now we're going to transition into the completing of the square method. And as we move to complete the square, it's going to lead us, take us to the square root method. So we'll start with completing the square, going through all of the processes for that. And we're going to get to a point where we have to pick up with the square root method from completing the square. All right, let's take a look at it. So, if we are completing the square with a equals 1, given ax squared plus bx plus c equals 0. So that means that the lead coefficient, this a right here, has to equal what number? 1. A must equal 1. Okay? Equals 0. So the point I want to make is that when you're constructing trinomials that will become binomial squares, this process is called completing the square, where x squared plus bx plus b divided by 2 quantity squared equals x plus b divided by 2. That quantity is also what? Squared. And you're saying, Mr. Wright, what did you just say? Tell you what, let's do some examples and we'll kind of make this plain and easier for you to understand as we go along. Alright? I know you've written it down already. Let's just work on it so I can show you exactly what we're talking about. Alright? Alright, example 1. Here we go. Example 1. Alright? Let's say that 3x, solve for x. Let's say that 3x squared, right? 3x squared equals negative 12x plus 33. Okay? 3x squared equals negative 12x plus 33. Okay? Let's work on that. Alright, so the first thing that we want to do in this case, the first thing we want to do, right, is wherever you see a variable, like an x, put all the variables on one side and put the constant term on the other side. Okay? In other words, here's the equal sign right here. And if you have a variable like an x squared or x, they should be together. And the constant 33 should be by itself. So what I'm going to do, I'm going to add 12x to both sides. And notice now, I cannot add these two together because they're not like terms. They're not like. I can't say, oh, that's going to be 15x. It's not 15x, nor is it 15x squared. You cannot combine those terms because they're not like terms. Why? Because one is x squared and the other is just x. So they're not like terms. So take what's written, vertically and just write it horizontal. So it's going to become 3x squared plus 12x. See that? You take the vertical, write it horizontal. 3x squared plus 12x equals, on this side the 12x's cancel out. See that? A minus 12x plus a positive 12x, that's 0, so don't even write that. But don't forget this 33 now. Bring that straight down. Equals 33. Okay, you good? Everybody good? All right. Now, we said that A, right here, A has to equal 1. A is this first number right here. That has to be a 1. And right now, A is not 1, A is what? 3. So in order for us to make this a 1, let's divide by 3. Divide each term by 3. Three over 3 cancels out. And now we have a 1. So x squared. And guess what? There is a 1 right here. That's what we want. You cannot complete the square if that is not a 1. That lead term must be a what? 1. Alright. So my x squared term is a 1. See? X squared term has to be a 1. The x squared term must be a 1. Okay, we have it now. So it's 1. So x squared plus 12 divided by 3 is 4. And what is this going to equal? 33 divided by 3 is 11. Alright, very good. We're on our way now. And so now we can kind of see where the red comes into play right here. Alright? Watch this. Here we go. Hopefully there are no questions to what we did right here, because all we did was we added and divided. 2 of the 4 basic operations in arithmetic and mathematics. We added and we divided. So you should be okay with that. Now to complete the square, okay, we're going to have to take a look at this b right here. Alright? This b, which is the coefficient of x. Okay? What number is right next to x? Well, in our case it's 4. 4 is the coefficient of x. 4 is the coefficient of x. So what's going to go right here? I'm going to write it in red. What's going to go right here? Well, I must take b divided by 2 and square it. Okay. So plus, here we go. Take b, which is 4, divided by 2, and then square it. There you go. Whatever this number is, b, to get to this next step right here, you have to take the b, divided by 2, and square it. My b was 4. I'll put 4 right here, divided by 2, and I squared it. You see that? Now, here's the thing. Don't miss this. What I did right here, if I do it on one side of the equal sign, I have to keep the equation balanced. I just can't add something to one side and not the other. So in fact, let me show you how I'm going to do that. Let me make this all red. Let me make it all red. Okay? So what I did on one side, I must also do it on the other side. So I have to add 4 divided by 2 squared over here as well. Okay? Because I have to keep the equation balanced. I just can't put something on one side and not the other side. Then the equation is not balanced. What you do for one, you must do for the other. I always use this analogy because I have twin sons, right? And as they were growing up, they're grown, they're adults now. But as they were growing up as children, I couldn't buy one a truck and not buy the other one, a car or a truck, another truck. What I do for one, I must do for the other because I had to keep it balanced. You see that? Equations have to be balanced. So, if I add 4 divided by 2 quantity squared on one side, I must add 4 divided by 2 quantity squared on the other side. Now it goes downhill. Okay, here we go. So we're going to have x squared plus 4x plus, take your time right here, do us on the inside and then square it. All right? Let's do what's on the inside. And then square. So I got 4 over 2 and it's squared. First things first. Does anyone know what 4 divided by 2 is? Do you know? Do you know? Do you know? Very good. It's 2. So that's going to give us 2 squared. Okay, now do this piece. Does anyone know what 2 squared is? That means 2 times 2. Do you know? Do you know? Do you know? Good. It's 4. So I'm going to go back here and I'm going to write this plus 4. And this is going to equal 11 plus 4. Okay? Now, here we go. You see this trinomial square? You see this trinomial square? Bop, 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 bop. This trinomial square piece represents the red right here. Okay? That's what this is. All right? So this is the same thing as x squared plus bx plus b divided by 2 squared. Same thing. Okay? Now what you can do is take this trinomial square, because that's what it's called. This is called a trinomial square. Trinomial square. Trinomial because it has 3 terms. 1, 2, 3. Square because the first and last terms are perfect squares. Perfect square first, perfect square last. Okay? It just so happens the middle term is also a perfect square, but it's not always the case. Perfect square first, perfect square last. All right? And so, let's see. Now we want to rewrite it again. Because you know what this equals. B squared plus b, x squared plus bx plus quantity b squared divided by 2 squared. Well, that's also equal to this right here. So now I can write this as, okay, x plus b over 2 quantity squared. We can write it that way. So let's do that. So now this becomes x plus 4 over 2 quantity squared. And this right here is what we call a binomial square. So you can write the trinomial square as a binomial square. That's the point. Write the trinomial square as a binomial square. Okay? And all of this still is going to equal 11 plus 4. What's 11 plus 4? 15. All right. Let me erase this. Let's take it on up a little higher. Let's come right here now. All right, so that's going to be x plus, all right, and we know 4 divided by 2 is 2. X plus 2 squared equals 15. Now, what do you think we do right here? Think about that for a minute. Think about it. What should we do at this step right here? What do you think? You got it. If you said, now return back to the square root method, there you go. So we have to complete the square. And once we completed the square, write it as a binomial square. Now return to the square root method. All right? Let's go. So we're going to have x plus 2 quantity squared equals 15. And we're going to have to put our square root here, plus or minus the square root there. Okay? The square and the square root will cancel. The square root, the square cancel. So I'm left with x plus 2 equals plus or minus the square root of 15. Okay? Let's go ahead and subtract 2 from both sides. Minus 2, minus 2. If I do that, I'm going to have x equals, again, write this bottom number first, negative 2 plus or minus the square root of 15. All right? There is no need for us to break down the square root of 15. Right? No need. Because you can't, there are no groupings. There are no groupings, right? There are no groupings. Look, the square root of 15, well, what does that equal? Well, if I break down 15, it's just 3 times 5. They're already prime numbers. I can't group by 2's. So since I can't group according to the index, leave it alone. That's it. Split it up. So x equals negative 2 plus root 15, or x equals negative 2 minus root 15. And there are your two solutions. 1 and possibly 2. And that's it. That was a lot. As you're taking notes on this, ladies and gentlemen, I want you to put a star or an asterisk around this step right here. Stay here. This is critical for a second. Put a star or asterisk at that spot, because I'm going to do another example, but then I'm going to come back and show you another method that can put you right here without necessarily having to go through all of this. Okay, so put a star around x plus 2 equals plus or minus the root of 15, and I'll come back and give that to you shortly. Okay? All right. Let's erase. Let's look at another example. All right. That's gone. We're going to look at maybe 2 more examples. 2 more. Okay, what's next? Let's see. All right. Here you go. Let's try 2, 12, 6. Example number 2. Let's say 2x squared plus 12x minus 6 equals 0. All right? That's right. Let's make this plus 6. I'm sorry. Plus 6. 2x squared plus 12x plus 6 equals 0. What do we do? Well, there are a couple things. There are 2 ways you can approach it. Okay? First, you can either take the constant term and move it to the other side, just move it on over, or you can divide both sides, or divide everything by 2, because you want a 1 right here. It doesn't matter how you're going to start this thing. It's up to you. Okay? It's up to you. All right? So the first thing I'm going to do is I'm going to take this minus 6, subtract 6 from both sides. And if I do that, I'm going to get 2x squared plus 12x equals negative 6. And then I'm going to divide everything by what number? 2. Because I need a 1 right here in front. So I must get rid of that lead coefficient of 2 and produce a 1. And so the 2's cancel out. And guess what? Congratulations. X. I have my 1x squared. I have my 1x squared there. Great. All right. Plus 12 divided by 2, 6x. And what does that equal? Negative 6 divided by 2 is negative what? 3. All right. And so once again, ladies and gentlemen, we are set up now. We're in a good position. We're in a good position to utilize our red. Utilize the red. Utilize the red. So what's going to go right here is half of this number and then square it. half of the linear, we call it the linear term, right? It's called the linear term. We have the quadratic term, the linear term, and the constant term. See, A is the quadratic term. AX squared, that's the quadratic term. BX, that's the linear term. And C is the constant term. So we have the quadratic term, the linear term, and the constant term. And so we take the coefficient of the linear term. The coefficient of the linear term is 6, right? And so what goes right here is plus, here we go, we take that coefficient, which is 6, take half of it, and square it. And what you do for one side, you must do for the what? Other side. Plus half of the coefficient of the linear term, that quantity squared. All right. So now we're not looking too bad. Okay? And quite frankly, I didn't do this with the last problem, but watch this. Look. Look. Look at this. Look at, come in real close. Zoom in. Zoom in. Make the screen big. Watch this. If you write it or express your trinomial square, this is the trinomial. The trinomial square. If you express it like this, I can go now directly to the binomial square. Because the binomial square is right here. It's x plus b over 2. Well, b over 2, the same b over 2 here is the b over 2 right here. So now I can write this as x, parenthesis, parenthesis, and then x, plus b over 2, or the b over 2 is 6 over 2. 6 over 2 quantity squared equal. See that? You can go straight from the trinomial square straight into the binomial square. In fact, let me keep it all color coordinated for you. Let me write this red. 6 over 2. There you go. You can go from here directly to here. Direct shot. Directly. Let's do some work over here now. Let's work that out. What's that going to give us? Well, that's going to be negative 3 plus 6 divided by 2. Do you know 6 divided by 2? Do you know? Do you know? Do you know? 3? Very good. So 6 divided by 2 is 3. Now you take that 3 and square it. Do you know what 3 squared is? Do you know? Do you know? Do you know? Good. 9. Ladies and gentlemen, when you are completing the square, the years has taught me that students' most difficult part in completing the square is this right here. That part right there. Taking half of the linear term, that quantity, and then squaring it. That just blows their mind. Well, there you go. Alright? So that's going to give us a 9. So this right here is going to be 9. So we have negative 3 plus 9. What is negative 3 plus 9? Do you know? Do you know? Do you know? If you say 6, congratulations. That equals 6. So what do we have here? We're going to have x plus 6 divided by 2 is 3. 3 squared equals 6. There we go. And now we're back to the square root method. Okay? So I have x plus 3 quantity squared equals 6. Square root both sides. Square root the left. Plus or minus square root the right. And I'm going to get the square root and the square cancels. So I'm going to have x plus 3 equals plus or minus the square root of 6. All right, let's proceed to subtract 3 from both sides. And so x is now going to equal, write this number first, negative 3 plus or minus the square root of 6. There's no need in breaking down the square root of 6 because the square root of 6 is just 2 times 3. They're both prime numbers. You can't group by 2, so leave it. You're done. So x equals negative 3 plus the square root of 6. Or x equals negative 3 minus the square root of 6. That's a wrap. All done. You good? Not bad. All right, let's do one more. This is our third example. Okay. Example 3. All right. Let's say, what if we have x squared minus 7x plus 12 equals 0. Okay. The good news with this example, at least we know this. At least we know that we have a 1 already here. See, that's a 1 right there. So that satisfies our condition with a equaling 1. A is a 1. A equals 1 because we have a 1 that's already there. So we're good. So since we know a is already 1, let's just go ahead and move to 12. Let's subtract 12 from both sides. Minus 12 left, minus 12 right. And so we're going to have x squared minus 7x. What is that going to equal? Negative 12. Okay, so far so good. All right. And so here we go. Now we're ready for the red. Let's tackle the red now. Okay. In tackling the red, the trinomial square is going to be x squared minus 7x plus, here we go. Take 7, because that's the linear term, that's the coefficient of the linear term. All right, 7 divided by 2, and do what to it? Square it. Now listen, some of you all are saying, no, Mr. Wright, that's not right. It should be negative 7. Okay, make it negative 7. Look, here's the point. If I take 7 and square it, that's the same thing as negative 7 squared. They're the same. So since I'm squaring it, I can write that as negative 7, or I can leave it as positive 7. And I know many of us, we don't like dealing with negatives. But when I square that quantity, it's going to be positive. Okay? So you can write it as negative 7 or positive 7. All right? And so let's go ahead and just write negative 7. We can write negative 7. Since that coefficient is negative 7, we'll write negative 7. No problem. Okay, well, what's on the other side? Equals negative 12 plus, write the same thing on the other side. Negative 7 over 2 quantity squared. Everybody good? Good? Okay. Let's go ahead and write our trinomial square as a binomial square. All right? So here's what we're going to have. We're going to have x plus this part right here. negative 7 over 2, and this whole thing is squared. All right. And that equals negative 12 plus, okay, now we have work to do. Okay? We need to know what negative 7 divided by 2, that quantity squared, is. All right, that's going to be plus a negative 49 over 4. All right, so let's go back over here. So that's going to be x minus 7 divided by 2 quantity squared. Why is it minus? All right, it's minus because, watch this, whenever you have a positive times a negative times a negative is a negative. And I guess that's why it was important for us to write the negative sign right there, because a positive times a negative, that is a negative. All right, well, what does that equal? It equals negative 12, and here we have it again. You see this? A positive times a negative is a negative. So we're going to have negative 12 minus 49 divided by 4. All right? I mean, if you have a calculator, go ahead and use your calculator. That might be the best way to do it, or to go about it. But if you don't have a calculator, we just have to work the problem out. All right, here we go. Negative 12 minus 49 divided by 4 equals, let's write this as negative 48 over 4 minus 49 over 4. So I wrote negative 12 as negative 48 divided by 4, because 48 divided by 4, negative 48 divided by 4 is negative 12. So I just rewrote negative 12, okay? Which equals, what's that going to give us? Negative 97 over 4. So that's what we get, negative 97 divided by 4. All right? So we're going to have x minus 7 halves quantity squared equals negative 97 over 4. All right? So now what we want to do, take the square root, because now we have the square root method, take the square root of both sides. Let's do that. So we have the square root of x minus 7 halves quantity squared equals plus or minus the square root of negative 97 over 4. And once again, you have to go back now to lesson 6.1. This is important. Watch this. Notice this, that my square root and my square cancels, so I have x minus 7 halves equal. Uh-oh. What do you notice about this section right here? Plus or minus what? What do you notice about that? What do you notice? Is the negative inside the radical or outside the radical? Okay? If the negative is inside of the radical, and if the index is a positive even number, then this has what? No solution. Right. This right here, no solution. Because you can't have a negative inside the radical with an index that is an even number. Okay? So we can stop right here. That's square root negative 97 over 4. This right here is no solution. That's no solution. That's not going to work out. Those are imaginary solutions, which we talk about in later lessons in another class, not in this class, okay? But you would only know this right here is no solution if and only if you go back to lesson, guess which lesson? Yeah, 6.1, because we covered these problems in 6.1. That's no solution, okay? So this is how you do this type of problem. One thing I also want to stress is that when you have a linear term that has a odd coefficient, you're going to have fractions, so you can't be afraid to add and subtract the fractions, because you're going to have a fraction, okay? You're going to have a fraction. All right, very good. So there's one more thing I want to get to. One more thing that I want to say to you. Let me see. Given ax squared plus bx plus c, where x does not equal 0, if you're given that, then x plus b over 2a squared is going to equal b squared minus 4ac all over 4a squared. Yep. This is a shortcut to get to the square root method. This is a shortcut to square root method. That's a shortcut to the square root method. All right. Let's go back to our example I told you a while back. Let me see. It was 3x squared. 3x squared, and it equaled 12x plus 33. Negative 12x plus 33. And this one, remember, it was solved for x, right? And what you could do is the 12x, we added 12x to both sides. This was the problem I told you to put an asterisk by a certain spot. We added 12x to both sides, and we got 3x squared, right, plus 12x equal 33, right? And if you want to, let's go a step further and divide everything by 3, and you get x squared plus 4x equals 11. And then if you subtract 11 on both sides, minus 11 minus 11, what are we going to get? You're going to get x squared plus 4x minus 11 equals 0. Okay, so if you write it like that, oh, I left off something here. This is important. Equal 0, where a cannot equal 0. Yeah. There you go. Make the whole equation equal 0. Write it in standard form, where the whole thing equals 0. That's what I have right here. Okay? Equals 0. That'll get you ready. That'll set you up in a position. You can go from here directly to like the square root method if you care to, without completing the square, right? You have to know a few things though. Here we go. You have to know that a equals 1, because there's a 1 right here. You have to know that b equals 4, because there's a 4 right there. And you have to know that c is negative 11, because that's where negative 11 right there. If you know a, b, and c, plug it in, and that's it. Literally. We know a, we know b, you know c, plug it in. Check it out. X plus 4 divided by 2 times 1 equal x plus b, b is 4, 4, divided by 2 times a is 1, equals b squared, equals 4 squared, minus 4 times 1 times negative 11, all divided by 4 times 1 squared. And see, once you get to this step, it's all about arithmetic now. Just do the arithmetic and you're done. Okay? Just do the arithmetic on it. So the arithmetic is going to give us x plus, well, 2 times 1 is 2. 4 divided by 2 is 2. Oh, put the square here. Don't forget the square. See? Squared. Put the square there. 4 divided by 2 is 2 squared. And if you go back to where I told you to put the asterisks, you're going to see x plus 2 squared. X plus 2, that quantity is squared right there. And once you do the arithmetic right here, you better get 15. Let's see. Equals 4 squared is 16. We have a negative 4 times 1 times negative 11. That's going to be a plus 44. All divided by 4 times 1 squared is 4. Right? Which is going to give us x plus 2 quantity squared, which equals 16. 16 divided by 4 is 4, plus 44 divided by 4 is 11, which equals x plus 2 squared, which equals 15. And there you go. And now you're set up for the square root method to solve that without necessarily going through completing the square. We did not complete the square. Okay? We had to do this first. We had to first put it in what we call standard form. Standard form. Put it in standard form and then you're good. You got it. And you can pick up right there. We'll put the asterisks. Okay? Let me see. If we look at the other problem we did, let's look at the other problem. Let's look at the other problem we did. And I'm going to use the same method. I'm going to use the same method. We looked at 2x squared plus 12x plus 6. We looked at 2x squared plus 12x plus 6 equals 0. Remember we did that one? That was the second example. Okay? Notice this, if you will. On the second example, I'm already in standard form. See, I have a 0 on the right side, 0 on the right side. Okay? If you want, you don't have to divide by 2 in this case. Just identify ABC and keep it moving. Let's do it. Come on. A is 2 right here. B is 12 right there. And C is 6 right here. Put it in. Put it in. So what do we know? X plus B. What is B? 12 divided by 2 times A. 2 times A. What is A? 2. Close it off. Square it. Equals B squared. That's going to be 12 squared minus 4 times A times C. 4 times 2 times 6. All divided by 4 times A. What is A? A is 2. Times 2 squared. Do the arithmetic, which is what gives students the most difficulty, the arithmetic. That's where you mess up. If you're not careful, you'll mess up right there. Okay? Here we go. So we're going to have x plus 12 divided by 2 times 2 is 4. 12 divided by 4 is 3. So we have x plus 3 quantity squared. If you go back and look at this example, you're going to see x plus 3 quantity squared. See that? Come on. Equals 12 squared is 144. All right. And then we have 4 times 2 times 6. That's going to be minus 48. 4 times 2 times 6 is 48. All divided by, all right, we have 2 squared. Do not say 4 times 2 first. That's not order of operations. You're wrong. You can't say 4 times 2 and then square it. No, you must take the 2, square that first. 2 squared is 4. And then 4 times 4 is 16. All right. And that's going to give us x plus 3, quantity squared, which equals, all right, 16 into 144. How many times does 16 go into 144? Maybe 8, no, 5, 4, 3, let's see, let's try maybe 6 times. 6 carry a 3. No, let's try 9 times maybe. 16 and 9. That's going to give me 4, carry a 5. Yep, 9 times. It's going to go 9 times. 16 into 144 is 9. So 16 goes into 144 9 times. Minus 16 goes into 48 3 times. You see how we did that? 144 minus 48 over 16. That's the same thing as 144 over 16 minus 48 over 16, which equals 9 minus 3. Okay? If you want, you could have added these, subtracted these first, and then divide by 16. Doesn't matter. And there you go. So we're going to get x plus 3, quantity squared, equals 6. And that's where we were a while ago when we did that example. Okay? So you can use the complete and square method and get to this point in the problem where you have to use the square root method, or you can use this algorithm here and go straight to here and then pick up the square root method there. Okay? All right, that's 7.1. I'm finished with it. Practice 7.1. If you have any questions, comments, issues, scares, concerns, worries, woes, didn't get it, couldn't get it, redos, do-over, retry, whatever the problem may be, whatever your issue is, please shoot me an email and I'll be more than happy to respond and to help you out. Thank you so much for listening. Thanks for paying me some attention, giving me some of your time. Please watch the video, go back, pause it, try the problems again, and I'll be talking to you and seeing you very, very soon. All right. Thank you. Take care. And whatever you do, stay positive. Hello again. Welcome back. And now we're going to look at lesson 7.2. Hope you're doing well. I hope you're practicing, social distancing, keeping your hands washed, and stay home. Don't go nowhere. Take it easy and watch these videos. Anyway, all right. Today's lesson is lesson 7.2, which is the quadratic formula. So, what I'm going to do, as always, I'm going to get out your way. Copy the notes down, and once you copy them down, I'll come right back and we'll work it out. We'll work it out together, you and me. We'll work through them, okay? All right. So, start copying, and I'm going to move out your way. Move out your way. We're back. Thank you. Thank you. All right, let's talk about it now. There's several things here let's get into it. All right, here we go. So, quadratic formula. If ax squared plus bx squared plus c equals 0, please notice that that's in standard position. Must be in standard position. Oh, no, not standard position, standard form. Standard form. 0 on the right side and everything else on the left side. A cannot be 0 because if a is 0, we don't have a quadratic. So a cannot be 0. Then, if these conditions are what they are, then we can say that x equals negative b squared plus the square root of b squared minus 4ac, all divided by 2a. That, ladies and gentlemen, is the quadratic formula. Okay? So this is what we're going to be using to solve and find out what x actually equals. Last lesson, 7.1, we found out what x equals using the square root method. Remember that square root method? And we said x equals 2 plus the square root of 5, or x equals 2 minus the square root of 5. Well, we found out what x equals using the square root method. This lesson, we're not going to use necessarily the square root method to find out what x equals. We're using the quadratic formula, or what some mathematicians call the beast, because it always works. There's no flaw. It's good. It's always good. So the value of x will equal negative b plus or minus the square root of b squared minus 4ac, all divided by what? 2a. That is the quadratic formula. Let me show you where students make a mistake with the quadratic formula. Here they go. Here's how students write it. They're going to write x equal the square root of b minus 4ac all over 2a. See, that's being lazy right there. That's lazy. That's called lazy right there. You know good and well that does not look anything like that. If you do that, you're going to be wrong because that's lazy writing. Okay, some do this. I'm not lazy, Mr. Right. It's negative b plus or minus the square root of b squared all over 4ac times 4ac all over 2a. And they stop it like right there. Really? Wrong. Another mistake. X equal negative b plus or minus the square root of b squared minus 4ac all over 2a. Wrong again. When you're writing the quadratic formula, you have to write it precise, accurately, correctly. You must write the square root of b squared minus 4ac, and the division line must cover all of that. It must be underneath all of it. Can't be like this one or like that one. Can't do that. This is all wrong. Do not make that mistake. And unfortunately, some of you probably will. Oh no. Oh. But don't you make that mistake. You've been warned. You've been warned. All right. Okay. So that's the quadratic formula, right? Here we go. And then there's the expression b squared minus 4ac. Notice that's within the radical of the quadratic formula. That's under the radical, isn't it? Yes, it is. B squared minus 4ac is called the discriminant. It discriminates. There's a judgment being made here. You see? The discriminant. And there are three cases to be considered. If the discriminant, b squared minus 4ac, is greater than 0, if you're greater than 0, that means you're positive. If this value is positive, I don't care what the value is, necessarily. I just want to know if you're positive or not. If it is positive, then there are two distinct real solutions. What's in green is going to be an answer to the question. That's the answer. The answer is two distinct real solutions. If the discriminant, b squared minus 4ac, equals 0, if it's actually 0, then the answer is there is one repeated real solution. And I say repeated because it's that same number twice. There has to be two answers, ladies and gentlemen. Two answers. Well, why two, Mr. Wright? Because a quadratic is squared. And the degree of the polynomial tells us how many solutions we ought to have. If it's squared, we ought to have two solutions, two answers, right? If this were a power of 1, we would have one solution or one answer. Remember that? For example, look, if I have x plus 4 equals 1, Well, what's my power right here? The power is 1. That means when I solve that, I'm only going to have one answer. Subtract 4 from both sides, and I get x equals -3. You see that? How many answers do we have? 1. Why do we have one answer? Because our power is 1. Likewise, if we have a quadratic and it's squared, we should have 2 solutions. If this were a power of 3, how many solutions should we have? I can't hear you. I'm showing you. Good. 3. Power of 4, 4 solutions. So on and so forth. You get it. Alright? So, since it's a quadratic formula, and if my answer is 0, I'm going to have one repeated real solution. So the answer is going to be 3, but it's going to be 2 3s. So x equals 3 or x equals 3. Okay? If the answer is 5, x equals 5 or x equals 5. So it's the same number repeated. Third and finally, if b squared minus 4ac is less than 0, if it's negative, then there are 2 non-real solutions. Then we have 2 numbers that are imaginary, and we have to have 2 imaginary numbers because this is mathematics. And if the quadratic, by nature it's squared, then it has to be 2 answers. Even if the answers are imaginary solutions, we have to have 2 answers, Even if we gotta, go to our imagination and get 2 imaginary numbers. All right, so look, point 1, 2, 3. I've drawn a little graph up here to kind of help you understand what we're talking about here with point 1, 2, 3. Look at the first point, all right? If b squared minus 4ac is positive, meaning greater than 0, then there are 2 different real solutions. This graph right here, number 1, it correlates with point number 1. Look at this graph right here. I have a coordinate plane and I have a purple graph on the coordinate plane, right? Notice that the purple graph touches the x-axis in 2 locations. 1, 2. Purple touches x-axis in 2 locations. Why 2 locations? Because those are what? 2 different real solutions. This solution could be a positive 5. This solution could be -1. But they're 2 different answers, 2 distinct solutions. Because purple, the graph, touches my coordinate plane, x and y axis, in 2 locations. Well, how about this second graph right here? This second coordinate plane, the second graph. Well, the second graph, number 2, correlates to number 2. If the discriminant is 0, then there is 1 repeated real solution. Well, notice this. I only touch the x-axis in 1 location. And in that 1 location, there's my solution. So let's go back a little bit. So in this case, this could be x equal -1 or x equals 5. If this is a 5 and this is -1 right there. In the second case, let's say this right here is 3. Then this means that x equals 3 or x equals 3. But you only have to write it once. But you need to know it's 1 repeated. The number repeats itself. 1 repeated real solution. In this case, x does not touch the x-axis at all. So we have like an imaginary number, which is what? 2 non-real. Non-real means imaginary. There you go. This means imaginary. Imaginary solution. You get imaginary numbers. And imaginary numbers it's like the number I. It's the number I. And the number I we're not going to deal with in our class too much. We're not going to talk about it. But it's the number I. And we get our imaginary solutions. So there you go. Quadratic formula, the discriminant cases, here's what they look like. And so now in this section right here, here are the problems, here are the directions for the problems or the examples we're going to look at. So first you're going to identify ABC, and then we're going to use b squared minus 4ac to determine the number of solutions, which is right here. And then we're going to solve using the quadratic formula, which is right there. All right, let's get on with it. Here we go. Example 1. Example 1 is on the board. All right? And we want to do what? Identify ABC first. So in order for us to identify ABC first, we have to put it in standard form. It has to look like this. It has to look like this in standard form with 0 on the right side. So here we go. So I'm going to have 6x squared minus 11x minus 35 equal 0. This 11x must be brought to the other side. 35 must also be brought to the other side. So you have to subtract 11x and 35 from both sides. Subtract it. And that's what we're going to get. And from here we can identify ABC. So A has to equal 6. B has to equal negative 11. And C has to equal negative 35. And that's it. That's it for part 1. That's it for the first dot, first point here. Identify ABC. You have to identify ABC when it's in standard form. Okay? The equation must be in standard form. It has to be in standard form for A, B, and C. It has to be in standard form. Put it in standard form, 0 on the right side, and then identify ABC. All right, that's done. Let's go to part 2. Part 2 says, use b squared minus 4ac to determine the number of solutions. Okay, well, I have to use, so now I must use b squared minus 4ac. Okay, let's use it. What is b? B is negative 11. So I'm going to have negative 11 squared minus 4 times, what is A? 6 times C, what is C? Negative 35. Okay, there we go. Once I get to this point, let me see what I want to get out. What I'm going to do, I'm going to use my calculator too. If you have a calculator, use it. Scientific, graphing, a basic 4-function calculator will do. All right? So I have negative 11 squared, which is going to give me 121. So I have my 121. All right? Now, be careful when you're multiplying, because watch this, because here's where you're going to miss it if you're not careful. I have a minus 4 and a minus 35. You see that? Minus 4, minus 35. Does anyone happen to know, or can you recall, what is a negative times a negative? Do you know what that is, a negative times a negative? If you said positive, you are correct. Good. So it's going to be plus right here. A positive, plus. Now multiply these 3 numbers. Where's my calculator? All right, here we go. Let me see. 4 times 6 times 35 is 840 plus 840. And 840 plus 121, that's going to give me 961. I have a question for you. Look at 961. Here it is, 961. Here I have a question. Question is, this 961, is it positive? Is it 0? Or is it negative? Now don't overthink it. It's a simple question. It's very simple. 961, is that number positive? Is that number 0? Is that number negative? No, it's not negative. No, it's not 0. But yes, it's what? Positive. So to answer the second bullet, all you have to do is say it's going to be what? 2 different real solutions. That's the answer. Write it. Here we go. Since b squared minus 4ac equals 961, we have, what do we have? We have 2 different real solutions. There you go. And that's the answer for that. 2 different real solutions. So in essence, here's what we have. So for ABC, we get this. Yay. For the discriminant, we get this. Yay. All right. And so now we're ready for the last part, which tells us to solve it. Go ahead and solve it now. Use the quadratic formula. All right. So then x then is going to equal, let me write it out. It's the quadratic formula. Here we go. X has to equal negative b plus or minus the square root of b squared minus 4ac, and all of this is divided by 2a. Remember, don't slack. Write that quadratic formula. Write it correctly. All right. Take a, b, and c and put it where it belongs. Fill everything in. So x is going to equal negative b. What is b? B is watch that. Watch that. Be very careful right here. This negative, bring it straight down. Right? And then b, bring that. Well, what is b in our case? B is negative 11. So it's the negative of negative 11. Yeah, you might want to pause the video and let that sink in. You might want to pause the video and let that sink in, because students definitely get that crossed. This negative out here, always bring it down. And then whatever b is distinctly, go back and bring b down as well. So it's the negative of b. It's the negative of negative 11, because that's what b is. All right, we're moving on. Plus or minus the square root of, ladies and gentlemen, I do not have to do this work right here. B squared minus 4ac. I do not have to do it because it's been done already in purple. Hello. Pause the tape. Pause the tape. Pause the video right here again. I do not have to do b squared minus 4ac. It's already been done in purple. What, Mr. Ray? What? I do not have to do the calculation for b squared minus 4ac. It's been done already. It's in purple. See? B squared minus 4ac. We did all that work and we got 461. There you go. So in here goes, 961. And here goes 961. We got 961. And it's all divided by 2 times what is a? A is 6. Okay. Calculations now. That's it. So x is going to equal, the negative of negative 11 is positive 11. Plus or minus the square root of, well, what is the square root of 961? Calculate it. Let me see here. Clear it out. Second square root 961 is 31. So I can write plus or minus 31 all over 12. Why? Because 2 times 6 is 12. There you go. Now be very careful when you write it out. So from here we have to say that x is going to equal 11 plus 31 over 12, or x equal 11 minus 31 over 12. And there are your 2 solutions. Because the plus and minus means you got to split it out. All right? Let's do the plus first. So x is going to equal, what's 11 plus 31? That is 42. 42 over 12. Okay. Can you reduce 42 over 12? They're both divisible probably by 6, which equals 6 go there 7, 6 go there 2. There you go, 7 halves. So x equals 7 halves. That's 1. Now take a look at x minus 11 minus 31. X equal 11 minus 31 over 12, which is 11 minus 31 is negative 20. Negative 20 over 12, which equals, you can reduce that, both of those by 4. Negative 5 over 3, and there you go. X equals negative 5 divided by 3, and there you have it. And there are your 2 solutions. And we've answered all 3 questions. Bop, bop, bop. That's how you do it. Find A, B, C. Determine the nature of the roots using the discriminant. And go ahead and determine what they are. Solve it. Good? Everybody good? Let's do another one. That's example 1. Okay, I'm going to erase example 1. Example 1 has to go. Now let's go grab example number 2. All right, get rid of that. Example 2. Let's see. All right. Example 2. This time, let's look at, how about negative x squared minus 24x minus 144 equals 0. Okay? All right, same instructions. Let's identify ABC. Let's identify ABC. So A equals, well, first of all, is it in standard form? Is it in standard form? Is 0 on our right side? Answer is yes. We don't have to manipulate anything. We're already in standard form. Because we have to be in standard form in order to find ABC. So we're in standard form. All right, so A. So A is negative 1, because that's what's right here. There's a 1 right here, negative 1. And what is B? B equals negative 24. And what is C? C is negative 144. All right, any questions about identifying A, B, and C? You good with A, B, and C? Okay, now, I need to, well, that's it for ABC. We have ABC. All right. Now let's go to see this part right here. Next point. What's the nature of the solutions? Nature of the roots. Let's find out. So let's do b squared minus 4ac. So now we got to go b squared minus 4ac. Okay, here we go. Let's plug everything in. What is b squared? B is what? Negative 24? Negative 24 squared minus 4 times a, negative 1, times c, negative 144. Okay? All right. Let's do the arithmetic on that. What's negative 24 cubed? I think that is 324. Let me just confirm. Let's see. 24, negative 24 squared, not cubed, squared. 24 squared is, oh, way off. It is 556. What am I thinking about? 18? 18 squared? Yeah, that's 324. Not, yeah, 18. Well, 24 is 556. All right. So negative 24 squared is 556. So we have 576. 576 576. All right, look at our signs here now. We have a minus sign, and a minus sign. Negative, negative, negative. A negative times a negative is a positive. And a positive times a negative is a negative. So this is going to be minus. Because a negative times a negative is a positive. And then that positive times another negative is a negative. So 4 times 1 times 144, which is going to be 144 times 4 is 576. Which equals 0. All right. So there we have it. We get 0. So we get 0. So what does that mean? We get a 0. Let's see. Is our discriminant 0? Is 0 positive? Is 0 0? Or is 0 a negative? Well, 0 is not negative and 0 is not positive. So there it is right there. So what is our answer? Our answer is up here in green. The answer is 1 repeated real solution. So write that. All right? That's what you have to write. We have 1 repeated real solution. 1 repeated real solution is what we have. All right. 1 repeated real solution. Let's go after that solution now. Quadratic formula, which says that x equals, here we go, x equals negative b plus or minus the square root of b squared minus 4ac, and all of this divided by 2a. All right, so x is going to equal negative, bring the negative straight down, and what is b? B is negative 24. Plus or minus the square root. Ladies and gentlemen, the work for the square root, what goes inside the radical, has already been done. We did it already. It's been done when we found the discriminant. You see this? B squared minus 4ac? I don't have to do that because b squared minus 4ac is done right here. And we know that b squared minus 4ac is 0. It's already been done. It's 0. So what you put right here is a 0. Put a 0 in there. All right, let's do that. 0 all over 2 times, what is a? A is negative 1. So x equals. The opposite of negative 24 is 24. Plus or minus. The square root of 0 is 0. So I have to write that at all. All divided by 2 times negative 1 is negative 2. Right? So bear in mind, I don't have to write this. Don't have to write it. Because the square root of 0 is just 0. And 24 plus or minus 0 is just 24. And this right here equals, what's 24 divided by negative 2? That's going to equal negative 12. So this means that x equals negative 12. That's your answer. Congratulations. That's it. If you want to be technical about it, here's really what it's saying. Our problem, our situation is a quadratic. So we have to have 2 answers. So the answer to our problem is x equals negative 12 twice. So it's really x equals negative 12 or x equals negative 12. There you go. It's a double root, or what? A repeated solution. It's the same as a double root. Same thing. So there you have it. But only write it one time. Just write it once. That's sufficient. So there's our answers. Bop, bop, bop. You good? Any questions? Comments? Issues? Cares? Concerns? All right, all right, all right. Let me say this, because this is also important. I did not have to use A equals negative 1, B equals negative 24, C equals negative 144. I did not have to do that. Check this out. Watch this. Watch this. We had negative x squared minus 24x minus 144 equals 0, right? I could have divided everything by negative 1. You could divide through by negative, okay? You can divide by negative or multiply by negative, same output, same result. So if I divided everything by negative 1, what you do to one side, you must do to the other side to keep it balanced. This is going to give me x squared plus 24x plus 144, and it still equals 0. So what you could have done, you could have used A equals 1, B equals 24, and C equals 144. You could have used that. In fact, I like that a little bit better because there are no negatives involved. Students make a mistake when there's negatives. If there are no negatives, you're good. And if you take these numbers right here and you plug it in, you're going to get the same result. So you can also use that as well. 1, 24, and 144. If you use these, you're going to be absolutely correct. If you use these for A, B, and C, you're going to be right. Either set, either one works for A, B, and C. And we get the same results if we plug them in. All right? Boom!